Hi everyone. In today's lesson, we're going to be looking at the different types of graphs, the most popular graphs that we tend to use. And we'll also be looking at what these, they're called measures of central tendency for single variable data. That's just a really fancy way of saying if I have a bunch of data, what are some of the most common measurements that we take? We'll talk about what single variable data is later, but for today, let's just concentrate on the types of graphs, their strengths and weaknesses, and how to create these measures of central tendency, some of which you already know. Okay, so let's take a look at the different types of graphs that we're going to need to know for this course. I think you've seen a lot of them before, for example, pie charts and circle graphs, bar graphs. You've probably seen a histogram and a line graph, but you might not have seen a stem and leaf plot or a box plot, or what's sometimes called a box and whisker plot. So we're going to spend a bit more time on these newer graphs, but let's also cover obviously the ones that we've seen before. So pie charts look like this, and what's really important with a pie chart is that it's accurate in terms of A, the percentages in the slices should all add up to 100%, and B, they should be relatively the same, relatively sized. So they should be maybe not exactly to scale, but for example, in this pie chart that you have, we can clearly see that 10% is smaller than 15, which is about half the size of 30, and then 30 and 15 look to be about the same size as the 45% piece. Okay, so they must add to 100 and also look reasonable. They should have a title, and it's easier to see if you use different colors for each slice and this kind of thing, okay? And either they're labeled or they have to have a legend. So I'm not really sure what we're looking at here exactly, but I can see that it's broken down into frogs, logs, dogs, and hogs, okay? So when I look at this graph, I know that all of these things should add to 100%. So which category was selected the least? I can see that logs were selected the least at 10%. Okay, what percentage of people chose both frogs and dogs? So maybe this is a question about what you like to have as a pet. Maybe you like to have a log as a pet. What percentage of people chose both frogs and dogs? We just add them together. So frogs is 15, dogs is 45. 60% of people chose frogs or dogs. All right, pretty easy. Now let's go to something I think would be new for you, stem and leaf plots. So if you think about a tree, on a tree you have different opportunities, or with each branch you have different opportunities for leaves to grow out of these branches. So if we want to think about a stem and leaf plot, what we can think of is the first digit, or the tens digit in this case, of this number acting as sort of the branch, and then the second digit, the ones digit, acting like the leaf. So instead of writing, for example, 11, 7, and 12, what you would do is look at the first digit of these three numbers, and you would put all the first digits. So the first digit of 7 is actually 0. Okay, you look at the first digits and you put them in the stems column. So for example, with 11, I would write in a 1 here and a 1 here to identify 11. For 7, I'm going to write a 0 as my stem and a 7 as my leaf. Now my next number is 12. I don't have to rewrite that tens column because I already have it. So I'm going to go to this row here and I'm going to add a 2. So I can see that from the 1 in the tens column and the 2 in the ones column, that actually ends up being 12. So if I were to look at, say, this column in reverse, or this row, I know that the numbers 30, 37, and 36 should be in my list of numbers, which they are. Okay, So the way I've written the left-hand side chart here, the stem plot, I can see that I was just really going from left to right in the order of my numbers. So I have 11, 7, 12. My next one was 48. My one after that was another 12. And then I have 23. And then I have another 12. Then I have 40, 45, etc. I think I missed something there. But you can see that I kind of did this in a random order, or in the order of the data set. Whereas this one, there's actually an O missing here. This is called an ordered stem plot, where you take all those same digits, but you rearrange the tens so that they're in order, okay? And also, they represent exactly the same thing. It's just a matter of if I'm asking you for a stem plot or an ordered stem plot, okay? What are the mode and median of the data? If you remember what the mode is, it's the number that appears the most in your set. So it's actually really easy to see the mode. And let's look at the right-hand side, the ordered stem plot. And I think it's pretty easy to see here, right here, that the biggest, or the number that appears the most has to be the number 12. Okay, what about the median? If you recall, the median is the middle of data, okay? So you can count in from the ends. Okay, so how might I do this? Well, basically, if I know how many numbers I have, let's count that. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and I would have to look at my ordered stem plot, because when it's in order, it'll tell me what number appears exactly in the middle. And in the middle of 19 is the 10th position. Okay, the 10th position has 9 numbers below it and 9 numbers above it. So let's count up to 10. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what that means is my median number is 23, 2 and 3, okay? So I can only find the median looking at an ordered stem plot, but I probably could have found the mode by looking at either one of these. All right, let's move on to a bar chart or a bar graph. I'm not going to spend too much time on this because I think you've seen this before. It's a visual display, and it's good to use if you're comparing amounts or frequencies of data. So it's used to be able to compare things easily and to make generalizations about the data very quickly. So again, you're going to want a descriptive title. You're going to want the x-axis with categories that include the title, but the y-axis ends up being the numbers per category, okay? This doesn't seem important, but there should be space between the bars. This is what distinguishes a bar graph from a histogram, which we're going to learn about later. Okay, so here's an example of a bar graph, something pretty simple. So I have soccer, basketball, I have different sports on the x-axis, and then I have the number of people who said that sport was their favorite. Let's make some conclusions about this data, okay? Let's look at categorical data. I would say one thing that jumps out at me is soccer was chosen the most as a favorite sport. Okay. What else can we say about this? Maybe outdoor sports seem more likely to be chosen, or chosen more, than indoor sports. Okay, so what do I mean by that? Well, I consider tennis, soccer, and baseball to be outdoor sports, and basketball could be both. I guess soccer could be both as well, but hockey is definitely an indoor sport. I'm going to scrap that. So just a reminder, this is words. Another thing we can say about this data is that it seems that sports played with a ball happen more than sports with a puck. Maybe not the most incredible conclusion, but it's not false, it's true. Okay, so where categorical data would concentrate on words, quantitative would concentrate on numbers. So if I wanted to look at this, we could say something like 7 people chose basketball. Okay, we could say something that 5 sports were surveyed. Right? We could say a total number of people. Surveyed was what? Well, we have 9, 7, 5, 2, and 6, which is 29. Okay? And I will say that this would be considered for me to be a good graph. It's very obvious what the question was. It was very obvious what the answers were and how many people answered the question. And it doesn't seem to me like a biased question either. Okay, what about a double bar graph? So again, this is nice, a nice way to present your data if you're comparing quantities. But as we can see, this one is a bit different, okay? Namely because it has a legend, but you're also answering the same question for 2 different groups, okay? So this graph looks to me like it's asking the number of visitors in the months of April, May, and June to a place. It doesn't matter where the place is, but we're comparing the number of adult visitors versus child visitors, okay? So we're going to look here to see how many children visited in June. So I can see that child visitors are given in blue, and I can also see that the month of June is over here. So I'm going to say 600 children visited in June. Which months did more children visit than adults? I think there's only one month, and that month is May. The title is not very informative. Make up a different, more informative title for this chart. So maybe I could leave this up to you. We can make this up. Let's say a number of visitors at the zoo. Number of visitors at the zoo. And then based on what's given to me, I can see that it's separated into adult visitors and child visitors, maybe because the ticket prices are different. Okay, let's move on to histograms. I said we would get into this. They're very similar to bar graphs, but the x-axis is quantitative, first of all, and the x-axis is also split into intervals, okay? So what you want to do is think about the x-axis as kind of like dividing it into buckets, okay? Well, we call them bins, actually. So, and also it's really important, I know it looks like these bars have like a teeny tiny little bit of space between them, but actually they're technically touching. So when I look at this histogram, I can see that, all right, so one of the buckets would be from 800 to this other point right here, which looks to me like it is 820, $825. So this bar here, okay, would represent the frequency of monthly salary of people that falls between 800 and 825. So a decision has to be made with what to do when someone earns exactly $825. Does it go into the left rectangle, or would it go into the right rectangle? And that's something you have to figure out on your own based on you make that decision when you're graphing your data. Okay, so we can still answer very similar questions, and let's just read through what it says here. Obviously, the intervals need to be labeled. So even though they're not all labeled with the $25 intervals, we can see that they're all the same. So this labeling is good enough. It's clear enough to me what the bins are. We need a title for the whole thing. We need a title for the x-axis. And the y-axis is always called frequency. So basically, you're looking at the number of people or items that fall into that bucket. Okay, so I can see that my x-axis is labeling this graph with the gross monthly salary. So if I look at which salary is most common, it would be this one, just because it has the biggest bar graph. So this one is between 900 and 925. Okay, so it can be anything between 900 and 925. Which salary range of $100 is most common? Okay, so if I were to put all of these between 900, or sorry, for example, is there more of a salary, is there a higher frequency between 800 and 900, between 900 and 1,000, between 1,000 and 1,100, etc.? So I think maybe if I were to look between 800 and 900, and then versus 900 and 1,000, that would really be the only ones worth looking at, because the other ones are too small. But I can see that this looks like, you know, maybe 75. This is closer to 90, maybe closer to 80. And then we've got 150. I think it's pretty clear that the highest range is between 900, or the most frequent range is between 900 and 1,000. So it makes it really easy to compare when it's in a histogram or in a bar graph. Okay, line graphs, I'm sure you've seen before. This was actually taken from a snapshot of Crescent's COVID-19 dashboard data, okay, just from last week, I believe. So line graphs are used to display data that changes continuously over time. And they allow us to see overall trends. And let's read this graph. And I can see that at the bottom there's a date. On the y-axis, there is a number, and then there's a legend. The blue line is absent for any reason, and the red line is absent due to illness and or isolation, which we could attribute to COVID. Okay, so what do you notice about this graph, and what do you wonder? So I'm going to pause here, and I'm going to ask you to pause as well, and I want you to make some conclusions here before we move on. And maybe talk amongst yourselves to see what you think. All right, now let's talk about how to identify which graph best displays different types of data. So let's look at these charts and let's see what we think. The table below, or next to us here, shows the number of sneakers sold by brand for this month. Which type of graph would best display this data, and why? Well, I think based on what we have, we can see that a bar graph would be good, because we have different categories. Okay, because we have different categories that we want to compare. Okay. So when I look at the names here of shoes, okay, I can see that I want to be able to create a graph whereby I can look at the bars of data and see which one and compare them easily, okay? The table to the right shows the humidity level recorded in a small town for 7 days. Which type of graph best demonstrates humidity level and why? I think here it's pretty clear to see that a line graph would do this because, okay, it changes over time. Okay, so we want to be able to see something like, something like this, okay? And we want to think of this as kind of like a continuous variable, right? Because the humidity levels have to go through, like I can't go from 51 right to 59 without going through 52, 53, 54, etc. So in that way, it's not like individual dots. It has to be connected by a line. Okay, the table below shows the composition of the Earth's atmosphere. Which type of graph best represents the composition of the Earth's atmosphere and why? So I think this would be best demonstrated with a pie chart. First of all, because it has percents. Okay, but also because the amount of data is pretty low. So we have 3 categories that should all add up to 100, and I think probably a pie chart would be good. And then we would have to be careful to make sure, that the 2% really does look like, 2%, and the 21% really does look like just 21%, something like that. Something like that. Okay. Which is the best type of graph to show the high and low temperature outside today in 4 different cities? Okay, so because we have 4 different cities, what we probably want to do is a double bar graph. So I'm going to put my temperature here. I'm going to put the cities here. Okay, and then I could do, whoopsie, this didn't look bad. So we can do their high temperature and a low temperature. Okay, so we'd have our city names, city 1, city 2, city 3, city 4, and we'd have our high and low temperature for the day. Okay, now we're going to get to these fancy words now, measures of central tendency, but I think you guys have already heard about mean, median, and mode. So the mean is the average value. Okay, we add up all the numbers and divide by the number of numbers. Okay. The median is the number that's right in the middle. Okay. So what we have to do is line up all the numbers from small to big. Okay. And if there are an odd number of numbers, we just take the middle number. Okay, but if there are even numbers, okay, there won't be a middle number of even numbers. So let's say if I listed 4 numbers and I asked you for the median, you couldn't do it because that's an even number of numbers. So what we do is we take the 2 middle numbers and average them. Okay. The mode is the most. Okay, so that sounds, the words kind of sound the same. So we want the number that appears the most. Okay. And it is possible to have a tie. And then what you do is you list all modes. Okay. What is the range? The range is the breadth or scope of numbers. So it's the highest high and the lowest low. Okay, it's the difference between those. So the range would be the maximum number, so the highest high, subtract the minimum number. So it's the difference between the maximum and the minimum. Okay, so let's say I asked 13 of my colleagues how many hours of sleep they get a night, and then collected this data. So, few people had, only 5 hours of sleep, one person had 9. Okay, so for this data set, what I want to do is find the mode, the range, and the mean. So what we might want to do, this could save us some time, is we can put this in an ordered list, okay? So what we're going to do is start it, okay, so I'm going to put my 5s in first, and I've got 1, 2, 3 6s. I've got 1, 2, 3, 4 7s. 1, 2, 3, 4. I've got 1, 2, 3 8s. 1, 2, 3. And I've got 1 9. Okay, so I can see that the mode is 7. The range would be the max minus the min, which is 9 minus 5. So the range is 4. Okay, so it's like how much it fans out. What is the mean? Well, I would have to add up all these numbers together. So 5 plus 5, 1, 2, 3, 2, 3, 4, 1, 2, 3, plus 9. And I'm going to divide by the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers, which becomes 89 over 13, which is 6.87, and we're going to round that to 7, okay, because it says rounded to the nearest whole number. Now, what is the median? Well, thankfully, I've already written this as a list of in order from smallest to biggest, and since there are 13 numbers, and that's an odd number of numbers, what I'm going to do is look for the 7th number, 1, 2, 3, 4, 5, 6, 7, because I know that's halfway, 1, 2, 3, 4, 5, 6. So I have 6 numbers here, I have 6 numbers here, and the one in the middle is the median. The median is 7. Okay, suppose that a 14th colleague, Mr. Kovacs, adds in that he slept 10 hours last night. Determine the new median. So what I'm going to do is take the data that I have. Okay, I'm going to try to erase maybe some of the markings. Okay, and what I'm going to do is add in Mr. Kovacs' data point, which is 10. Now, how do I find the middle when I now have 14 numbers? Well, what I'm going to do is I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to realize that I can actually average the middle two numbers, which are 7 and 7. The average, okay, is when I add the two things together and I divide by the number of numbers. So actually, my median is still 7. Okay, but I had to double check that to make sure that that's right. Okay, on the first 5 days of his holiday, Mr. Singer drove an average of 256 kilometers a day, and on the next 3 days, he drove an average of 172. What is the mean, meaning average, distance traveled per day over the 8 days. So what I'm going to do is take how many kilometers I drove in total, and I'm going to average it by dividing by the number of days. So in the first 5 days, it's 256 plus 256 plus 256, and I do that 5 times. So instead of writing that all down, what I'm going to do is write it as 256 times 5 plus 172 times 3, right? So he drove a total of 5 plus 3 equals 8 days. Okay, then we're going to add this together. So that's 1280 plus 516 divided by 8, which ends up being 224.5. Okay, so therefore he drove an average of 224.5 kilometers per day. All right, Miss Hancock's niece is taking an architecture class where the mark comes from 5 tests in total, all weighted equally. She scored 84, 76, 85, and 77 on her first 4 tests. What mark does she need to get on the 5th test to finish the year with an 82 average? So we're going to let X represent what she needs on her test. And to take the average, we're just going to add them all up plus X. So that's the mark on her last test. And including her last test that she hasn't written yet, that includes 5 tests. So I want my total number divided by 5 to be 82. Okay, so what I'm going to do is rewrite this as 322 plus X over 5. And then we're going to clear the fraction. So I'm going to multiply this side by 5. And I'm going to multiply this side by 5. I'm going to get 322 plus X equals 410. X is 88. So she needs 88%. So guys, what I want you to do now, please go to your homework, give it a shot, okay? And if you need any help, there is extra help at 7:45 any day except Wednesday, okay? Or send either me or Miss Hancock an email, and we'd be happy to help you.